Hi, welcome to the Plate Tectonics Lab video. Um, you're going to watch this video to gather data to record in your Plate Tectonics Lab. So you need to record in the data table here. But before we get started with the lab, we are going to address the three pre-lab questions, which are: what are the three types of crust in simulation? Arrange the crust in order of thickness, and arrange the crust in order of density. Okay, so let's take a look at what the simulation has available to us. At the bottom here, we have a toolbox, which has a ruler, so we can use that to measure thickness. It has a temperature gauge. If we were looking at temperature, we can measure relative temperatures of things, but we won't need that. And then it also has a density gauge, which we can use to measure the density of the crust. And that's going to help us for the first two pre-lab questions. We also have a toolbar here to help us change the view, which we'll play around with. And then finally, we have our types of crust. There are three types: continental crust, young oceanic crust, and old oceanic crust. So these are the three types. So why don't you go ahead and pause this video now and add that to your pre-lab questions. Okay, so now that we have the types of crust, let's just play around with the crust and see which ones are denser and thicker. Now, looking at this image, looking at the image itself, you can see that the continental looks a lot thicker than both types of oceanic crust. And to add the crust to, this sort of is the earth here, we just go ahead and move it, drag it up to this highlighted section. Now, because this is continental crust, this is green, there's like land here. And then for oceanic crust, it'll be underwater. So I'm going to add the show seawater just so it's easier to see which one's which. Okay. Now, we can easily see that clearly the continental is a lot thicker than the, we use young oceanic crust here. All right, let's reset it and compare the young oceanic crust, which I'll put to the left, and the old oceanic crust, which I'll put to the right. And I'll add my seawater on there. Notice that there's no line dividing it. Looking at it, you don't see a difference in thickness. So if I wanted to, I could use the ruler to see if there's any difference in thickness, but clearly they're about the same thickness. All right, so that means for the second pre-lab questions, arrange in order of increasing thickness. Clearly the one that's the thickest is the continental, so that's going to go at the end, because if it's increasing order, the largest value will go at the end there. And then here in the middle, you can go ahead and change that sign from a less than sign to an approximately equal sign. They're approximately the same, the young and the old oceanic crust. We can't tell the difference, at least not from this simulation, in terms of thickness. The last thing we're going to do is arrange it in order of increasing density. So which one's the densest and which one's the least dense. Okay, so let's go back to the simulation. So let's start by comparing young continental crust and young oceanic crust, and I'm going to add my seawater just so we can see the difference. All right, so here we have our density gauge, and in order to use a density gauge, see this little triangle at the end? That triangle has to be touching the object that you're measuring, and it can't be below that, it can't be above it, because it'll change the density. As you can see, if I raise it just above it, the density gauge, well, I guess in that case it didn't work, but if I do it below it, you can clearly see it's getting a lot denser. All right, so for the continental, it's pretty easy because it's fairly thick, so we have a lot of room to play with. But at any rate, the density of the continental crust is, if we just count the darker lines here by 2, so this is 2, 4, 6, 8, 10, 12, 14, and so it's about It's really close to the 16 mark on the density gauge, whatever that mark means. So we don't know the units here. So let's say it's like 15.8 or 15.9. So that's the density of the continentals, about 15.8, 15.9. What about for young oceanic crust? So again, I want to make sure I move my gauge so that it's not below, but it's directly on the crust there. All right, so continentals like 15.8, 15.9. Let's go ahead and see what this will be. So I'm going to count the dark lines as 2, 4, 6, 8, 10, 12, 14, 16. It's past the 16. And in fact, it's slightly to the right of the 17. So maybe this is like 17.1. So continental is like 15.8, 15.9. Young oceanic is 17.1. We want to try one more. Let's compare young and old. So I'm going to put the old to the right and then the young to the left. And I'm going to get show my seawater. Once again, you can't really see the difference, but just to remind you guys, young is on the left, old is on the right. Okay. So I'm going to get my density gauge. We already just established that the density of the young is about 17.1. All right, so let's see about the density of the old oceanic crust. All right, so I'm going to do my counting again. So 2, 4, 6, 8, 10, 12, 14, 16, 17. But this is sort of in the middle, but it looks like between 17 and 18. So I would say this is 17.5. So actually the old oceanic crust is slightly denser than the young oceanic crust. The old oceanic is the densest at 17.5, followed by the young oceanic, and then the continental is the least dense. So going to your pre-lab questions, and for this last one here, in terms of density, you would start by writing continental here, then young oceanic, followed by old oceanic. All right, now that we have that established, let's go ahead and do some simulations.